Hello, welcome to this course Machinery Fault Diagnosis and Signal Processing. Today's topic is Basics of Machinery Vibrations. In the introductory lecture, we have seen what is condition based monitoring. So, condition based monitoring is nothing but this practice is useful in the industry for detecting various faults in the machines, and not only detecting the presence of fault in the machine, but these CBM techniques also help in detecting the exact location of the fault, and in some cases it detects the remaining useful life of a component as well. There are various condition based monitoring techniques. These techniques are categorized into three categories. First is vibration and acoustic measurement, which basically includes shock pulse monitoring, spike energy analysis, sound pressure analysis, acoustic emission, vibration analysis, etc. etc. Then second category is temperature measurement, because whenever there is a deterioration in the machine, then there is increase in the friction. Because of that, the temperature of a component increases, and by monitoring the temperature of a component, you can actually detect the presence of fault in the machine. So that way temperature measurement is one of the important condition based monitoring. But the drawback of temperature measurement is that it doesn't give the exact location of the fault, and neither it gives the remaining useful life of a component. Then the third category is wear debris analysis, which includes spectrographic, oil analysis, ferrographic, and chip detection. So under wear debris analysis, the wear out parts, metal parts, are microscopically analyzed for the microstructures, and by analyzing the changes in the microstructures of the metal part, we can actually determine the amount of deterioration happens in a component. So these are the various CBM techniques. Now out of these CBM techniques, vibration analysis is considered to be a most comprehensive and popular technique. Now why vibration analysis is more popular and comprehensive technique, that is illustrated by this table. In the column we can see there are total 11 machine faults are listed, and in the top horizontal line the various CBM techniques are listed. So the various machine faults are imbalance, out of balance or imbalance in the rotor, misalignment in the shaft, maybe parallel or angular misalignments, then shaft bend, then bearing faults, gear faults, mechanical looseness, mechanical rubbing or friction, noise, cracking, leaking ball seats. So all these are machine faults. Now here we can see that the temperature analysis, which is one of the condition based monitoring technique, it is capable of detecting only 4 types of fault out of the 11 listed here. Similarly, the pressure analysis can detect only 2 types of faults, that is journal bearing damage and leaking ball seats. Similarly, flow analysis can detect only 1 type of fault. Oil analysis can detect 3 types of fault. But here we can see that vibration analysis is capable of handling 10 types of fault out of 11, and that is why vibration analysis is considered to be the most popular and comprehensive condition monitoring technique. Now we will see what is vibration analysis. So vibration analysis is nothing but whenever there is a deterioration in the machine, then the vibration signals associated with the machines also increases, and by analyzing those vibration signals we can detect the presence of fault and by having the knowledge of the rotational frequencies of various components, we can detect the exact location of the fault as well. Similarly, by vibration analysis, we can also calculate the remaining useful life of a component also. Now we will see some basics of machinery vibrations. As far as the definition of vibration is concerned, then vibration is defined as any deviation from the equilibrium is termed as vibration. Example of vibration is a pendulum which oscillates with simple harmonic motion. Most of the time these vibrations are undesirable, but in some cases vibrations are desirable as well. The example of desirable vibrations are the pneumatic hammer which is used to dig the road. So by imparting the vibrations in the pneumatic hammer, the digging process becomes very convenient, and so that is why pneumatic hammer comes under the category of desirable vibration. But in practical applications, most of the time the vibrations are undesirable phenomena, and every steps are taken by the design engineers to control the vibrations. Now this is a simple single degree of freedom system model of a vibrating component. Here we can see that a mass is suspended with the help of spring and a damper, and an external force F is acting downwards. If you see the free body diagram of this model, then the external force is acting downwards, and the stiffness force and the damping force are acting opposite to the externally applied force. The stiffness force and damping force basically try to oppose the external excitation force, and that is why the stiffness and damping is considered to be very, very important in the vibration control. So if you apply the Newton's second law, which says that the mass of the component multiply the acceleration is equal to the summation of all types of forces which are acting on that mass. So this is the equation of motion of a single degree of freedom system. Now this is a small example in which a plate having mass 0.78 kg is suspended with the help of 4 springs, and by knowing the stiffness of the springs and the mass of the plate, we can find out the natural frequency of the system. So here the natural frequency is calculated by formula 1/2 pi under root k by m. Now we have already seen that the vibration analysis helps in CBM not only for detecting the presence of fault, but also finding the exact location of the fault, and in some cases detecting the remaining useful life of a component. Now these vibrations can be measured in 3 various categories. Like vibration can be measured in terms of displacement, vibration can be measured in terms of velocity, and vibration can be measured in terms of acceleration. So whenever there is rotational speed is less, then it is recommended to measure the vibration in terms of displacement. When the rotational speed is moderate, then it is recommended to measure the vibration in terms of velocity. But for high frequency rotation, it is always recommended to measure the vibration in terms of acceleration. We will see these terms in very detail in the coming lectures. Thank you.